Almost every program we've written so far in this beginning Python series has assumed that everything goes right. Today, we deal with what happens when it doesn't. Errors are not failures, they're information. Python's error system is designed to tell you exactly what went wrong and where. Knowing how to read that information and how to handle errors gracefully is what separates code that works in a notebook from code that works in the real world. Welcome to Mathy Python, where we talk about math, Python, and Mathy Python. When Python hits an error it cannot recover from, it raises an exception and prints a traceback. Let's look at one deliberately. So I define a function called divide, two numbers, a and b, and we will return a divided by b. Now let's try to divide 10 and 0. Read a traceback from the bottom up. The last line is the error type and message. That's the answer. So here it tells you zero division error, division by 0. So that's what went wrong. Everything above it is the call stack, which shows you the path Python took to get there. The error was from the function, and in the line return a divided by b. That tripped it up because it's trying to divide by 0. That was called by the line 4 that said to divide 10 by 0. This is a simple one. In a real program, the call stack might be 10 levels deep. The strategy is the same. Read it from the bottom. Very bottom, that gives you the error, and then you can trace it up. The basic structure to catch and handle an exception is something called a try except block. So in this case, we could say try result equals divide and 0. So that's everything that we want to perform in the program. The except is what happens if there is a particular error. So in this case, a zero division error. And in this case, we will print, I had enter too early, we'll print cannot divide by 0. There we go. So we try the stuff in the try block. The result will be divide 10 by 0. That creates this error, zero division error. So the program drops into this block and it prints cannot divide by 0. Python runs the try block. If an exception is raised, it checks whether the exception matches the one named in except. If it does, it runs the except block instead of crashing. You should always name the specific exception that you're catching. This works, but is bad practice. If I say, well, let's just copy paste. So if I just say except and I don't list the specific exception, it will still work. And what happens is any error that hasn't been caught will fall into this except. The problem with that is that it's too general. Any error will fall into this. So a bare except catches everything, including errors you didn't anticipate, and probably should not be silencing. It makes bugs harder to find, so name it. You can catch multiple exceptions. So in our try block, let's get an integer from the user. So we get an integer from the user, then we divide 10 by that number. And we have seen the zero division error. That's a possibility. I had tabs, so that would finish that out for me. Here I'll say cannot divide by 0 except value error. Print that was not a number. So either of these errors could occur. So enter a number. I'll spell out 4. That was not a number. So it went into the try block. X gets the number. Then the result is divide 10 by X. That calls the function. That's going to give this error, raise this error, the value error. It skips over the zero division error because we didn't get that. It'll give a 0 of a value error and tell us that is not a number. Okay, this time let's enter 0. And it tells me cannot divide by 0. So it got the function raised a zero division error, and that was caught. So each except clause catches a different exception type. Python checks them in order and runs the first one that matches. There are a number of common exception types. So a name error means that you used a name that is not defined. So for instance, print my variable. We have not defined that anywhere. So it tells me name error, my var is not defined. A type error is the wrong type for the operation. So if I say hello plus 5, I can concatenate strings using plus, and I can add numbers, but does it mean to add a number in a string? That's not real clear. So we get a type error, can only concatenate string, not int, to string. So that's the wrong type for the operation. Okay, we have a value error, which is the right type, but an invalid value. So if I try to make an integer out of the string 1.1, it does not know what to do that. It's a bridge too far for Python. It can make an integer out of 1.1 as a float, but it doesn't know how to make an integer out of a string out of a float. There's the zero division error, which is divide by 0. So we've already seen this one. 10 divided by 0 gives you a division by 0. So if you ask what is 10 divided by 0, what you're asking is what number times 0 gives you 10. Any number times 0 is 0. You can't get to 10. So that's a mathematical reason you cannot divide by 0. There's an index error. This means the index is out of range. So if I have scores equals 88, 99, 92, 75, and I say give me scores sub 10, that's an index error. There is no position 10, 0, 1, 2, anything from 3 onward. A key error occurs in a dictionary when the key does not exist. So let's say person is, let's make a very simple dictionary here. Just give it name and mark. And then I'll say person, look for age. I get a key error because there is no key age in this dictionary. File not found error means the file does not exist. So I say open missing dot text. You can see there is no missing dot text file in this directory. File not found. No such file or directory. Missing text. An attribute error means that the object does not have that method or attribute. So if I say my tuple is 1, 2, 3, my tuple, and then I try to append something to this, so I say my tuple append 4, this will not work. It would be fine as a list, but it's not a list, it's a tuple, and a tuple does not have that method on purpose so that you cannot change it after it's defined. So that gives you an attribute error. And then the syntax error. I've made a number of these during the series to show you how these work. This means that Python cannot parse what you wrote. It's usually a typo. So x equals 3. That's invalid syntax in Python. So here's a table that summarizes all of this. There are two keywords here we should talk about, else and finally. Else runs if no exception was raised. So let's say we try result equals divide into except, make a zero division error. To check that, we'll print cannot divide by 0. Else print, use an F string. Also indent that. And say the result is then the contents of the variable result. So the result is 5.0. Divide always gives you a float. The else block only runs when the try block succeeds. So it's cleaner than putting the success logic inside the try block, which you could do, but this is clear. This keeps the happy path separate from the error handling. Let's look at a finally block. In this case, I have a function called process batch. I pass it some scores, which will be a list. And then I'll go through the list and see how many scores are valid. So initially the valid count is 0. So we try for score and scores. So we're iterating over those. If the score is out of bounds, meaning it's less than 0 or more than 100, then we raise a value error. So we can raise errors this way. If we want to force an error within a program, then you raise whatever type of error and you give it a string that will print. Okay. If it is valid, then we will bump up that count by 1. And then we'll print all of the scores were valid and return the valid count. If there is an error, it won't get to the print statement here or the return, but it will still do this finally block. So either way, we print finish checking, reset and counter for the next batch, and then we reset this counter to be 0. And now I can call this on a couple of different scores. So let's process this batch of scores on 85, 90, 78. All 3 scores were valid. And then it prints finish checking, resetting counter for the next batch. And let's process the batch on something that's invalid. We'll use 85, let's say 200 is out of range. So that should give us an error. So we get this error, value error score out of range 200, which is what we created in line 6. So this raise a value error score out of range, which it did. So we successfully raised the error. And then it does the finally. So it finished checking, resetting counter for the next batch. Valid counter is now reset to 0. This will matter more once a function gets reused or called in a loop. Without finally, if an exception happened midway through a process batch, the reset line placed after try except would never execute since the exception propagates out of the function before it gets there. With finally, the reset is guaranteed. So let's see this with a list of lists, and then we will iterate through that. So our batches, we have 85, 90, 78. That one's good. 85, 200, 78. That 200 is invalid. The 60, 70, 80, that one's okay. So the issue here is whether the valid count would remain out of whack and not get reset when it hits this middle one before it gets to the last batch. So we go through the batches, we process the batch, we'll print the valid scores or say the batch failed. So in the first batch, all 3 scores were valid. We finish checking, reset the counter for the next batch. Then we check it on 85, 278. The batch failed because the score is out of range. And then for the third one, all 3, it did properly count to 3 without having that extra 2 from the batch before it. So I have a file name called scores.csv. I will try to open it and then read it in. If the file doesn't exist, I get a file not found error, and I print file not found. If the file name is does exist, then it will run the lines to read it in. And in this case, our file is not found. So we mentioned the file not found error in the last episode. So this is how you would check for that file not found and then do something with it. Okay, so you can raise exceptions yourself. So if you want to raise an error based on some condition that makes sense in your particular program, you can do that. So here we define circle area, give it a radius. If the radius is less than 0, does not make sense to have a negative radius. So we will raise a value error and then give it a message. Radius cannot be negative. And then return the value. So let's try it with circle area of -5. The radius is less than 0. That raises this value error, which it did. And it gives us the message. Radius cannot be negative. So when to handle errors or not. So handle an exception when you can do something useful with it. So you can tell the user what went wrong, try an alternative, or log it and continue. Silencing an error you cannot actually handle, just hides bugs. Let an exception propagate when you cannot recover from it at that level. So if a required file is missing and your program cannot run without it, then crashing with a clear traceback is better than catching the error and limping along with bad or incorrect data. So it seems a little counterintuitive that you might want to let a program crash, but in some circumstances, that actually is the right thing to do. If you don't have a data file, don't make it up. Raise an exception when your function receives input that violates its contract. A clear error message early is always better than a confusing result later. It's always better to have errors that you can see than incorrect results, which is a different kind of error later. So we covered tracebacks, try except, else, finally, raising exceptions, and when to handle errors versus not handling them. Error handling is not a safety net. It's part of writing code that communicates clearly. I don't know what that means. Edit that out. In the next episode, we will cover imports in the standard library. There are many tools that Python ships with that you don't have to install. You can just call it. So the time library, for instance, that we used in this episode, that's from the standard library. The notebook link is in the description. If you like this content, then please subscribe. Happy programming.